webcam because I tend to talk with my hands. And I'm going to show examples as I go, more or less, or at least something representative. Hello, welcome everybody. I'm Bruce Calder. I'm the VP of Consulting Services here at Claigan. So I'm going to talk about a lot of things today. I'm going to talk about how to keep up to speed on the changing restricted materials requirements. I'm going to talk a little bit up front about deadlines. I'm going to try to hammer home how much this is growing compared to, say, other sectors of product compliance that your company might be engaged in. Then I'm going to talk about different types of changes because it's the different types that have a big effect on what you have to do. There could be new regulations, which do happen actually, but more often what's changing your life is the regulations you know already are being updated, or the substance list is being updated. And I'll actually talk about examples and changing enforcement. That one's probably the most impactful when it occurs. I'll talk about that one. There's nothing like a change in enforcement strategy that'll affect things. One of the reasons people have been able to get away with data gathering for so long is the enforcement has, other than Prop 65, been relatively weak. And until the Prop 65 part where you have to list the substance comes online, that is still going to be somewhat borderline. What I'm going to do in each one of these sections, I'm also going to provide examples. So we'll also talk about some extremely modern requirements you may or may not be aware of. Give you good examples of each. We'll change your regulation, update regulation, so new regulation, changing regulation, new substance list, and changes of enforcement, like an example from right now. And then how to keep up to speed. And we're going to focus on today. You have to level set, the ongoing, the implementation, the technical side, because there's a technical element, there's words, and there's a technical element, and then everyone else. So the people here on this webinar are a subset of your company, and your knowledge base on these topics is probably vastly superior to other people in your company. They still need to know something about it, or at least know it exists. And then we'll do Q&A. So the idea here is about 50 minutes of webinar and then do Q&A at the end. If you have any questions, feel free to submit it in the control panel. And it could be about these processes. It could be about some of the regulations I talk about, or it could be in general. So this is an example of a lot of the deadlines coming up. 2024 has a few, not too bad. 2025 has a lot, which means you'll be doing the work in 2024. Your effort is in 2024 to do a lot of work for 2025. There's a lot of stuff on the go. Now, one of the key things is restricted materials regulation growing faster than any other product regulations. The electrical safety people, the EMC, they have some standard changes, but it's not the same world as what you're working in. You can ask them, how many new regulations have you had this year? Well, if it changes in the standards and there's, like talk about some country of this, yeah. You guys get multiple new regulations a year, and you get quite a few regulations updating, and you get usually at least a half a dozen, if not 8 to 10 restricted substance list updates, what is regulated under the regulations updates a year. It's quite dramatic. It's growing a lot faster. It's important also part to hammer home where the company's saying, hey, we want to reduce your compliance budget for restricted materials. And you're like, well, mine's growing faster than everyone else. And here's a good one. If you look at the newspaper articles about my stuff, not everybody else's stuff. And if it's newspaper article, it means new regulation. Stuff that's going to stop you at the border is the new stuff. So that's an important one to hammer home. Yours is growing. Your workload is going to be growing. And you need to the company needs to understand that. We can't poison the environment or people as much as we used to. Unfortunately, now a lot of jurisdictions, the substances that cause attention deficit and autism are not heavily regulated. That's still coming. So what we're going to still see in the future, right now, we're mostly dealing with reproductive toxins, carcinogens, and bioaccumulants. Someday we'll deal with oxidative stress chemicals, the ones that cause Alzheimer's, and that will further expand this. So as they move, in the last couple of years, we've seen a big movement into, many years ago, focused on cancer, eventually the phthalates, developmental toxicity, reproductive harm, stuff that causes attention deficit. And then more recently, we're moving to bioaccumulants. So we're getting more and more substance types. A lot of the new stuff, the POPs, persistent organic pollutants, are bioaccumulants. We're moving more and more in that. And eventually, over time, we'll start wandering into oxidative stress. So they might have a fancier name by then, the Alzheimer's chemicals. So fundamental rule of restricted materials compliance. There's actually 3, but we'll start with this one. The requirements you are most likely not compliant with are the ones you didn't know about. I normally actually refer to this as the things you're most likely not compliant with are the things you didn't know about, which is kind of self-evident. If you didn't know they exist, you're more likely to not be compliant for them because you never knew they existed. And that's a big part of this battle. A lot of what we focus on first is making sure you know it exists so you have a chance of doing something about it. One of the big also things we focus on is outputs, where knowing it is one thing, having information on it, on your products is another thing, but how do you turn it into an output? Because that's the whole point. A lot of companies have benefited for low enforcement, and so the outputs have not been properly focused. We focus everything on the outputs. So how do you stay in the know? How do you know about these things? How do you know? And a lot of times it's like know today, like even just knowing what your product has to be compliant with today, the today thing is a big deal, but also the ongoing. So we're going to talk about today, the ongoing, and we're also going to talk about technical. There's difference between, hey, you need to be compliant with this, and then this chemical is found here for this reason, and that's why it's at risk for you, the technical. So we're going to talk about the today, the ongoing, and definitely the technical. So one of the reasons change is new regulations. New regulations are actually much more common in this industry than everyone else. Everywhere else, you're more likely to see regulations change than new ones. We are seeing new ones. The new U.S. state PFAS reporting is new. And you see more, the U.S. state level ones are based on a model legislation around 12 or 14 U.S. states agreed upon. And then they're slowly wandering through the legislatures of 12 to 14 U.S. states. So you're going to see PFAS reporting type requirements in 12 to 14 states with some variations, but they all started the same. Like California and Colorado, Minnesota, and Maine, they all had the same starting legislation. By the time it got to the other end, their own legislatures tend to change things. Minnesota's is the one closest to the original version. The EU battery regulation, I'm sure there's an EU battery directive, but it is a new whole regulation. There is relation, so it's kind of a change, but it is a totally new legislation. And Canadian plastics reporting, which a lot of companies may or may not be aware of. So for example, new stuff that you may not be aware of. Canada's planning a registry. By the way, anytime you see in these presentations of ours, these little purpley blue underlined things, those are hyperlinks. So everybody who registered will receive a copy of these slides, and you can click on it and it will go to the webpage for Canada for this. Unfortunately, it's Canada, and even though it's in English, I think our government motto should be unnecessarily complicated. It's not the easiest read. Everything's there, but not in a great way. I wouldn't give, if they are marked in the paper, a high mark for salient details. They really need like a guidance or a fact sheet or just consolidated. Then again, US TSCA is worse. So they're planning a registry for reporting of all plastics and electronics and packaging, and also single-use products. So in scope is packaging, also single-use plastics, electronic and electrical equipment. So this is EEEs based on the ROHS, EEE, except for they got it backwards. It's electrical and electronic equipment, electrical and electronic in the EU, but they went electronic and electrical, it's the other way around. Whatever, it's electronics, agricultural products, white goods, so somehow stoves and fridges are in a different category, textiles, automotive, and construction. So if you make any of these things or have single-use plastics that are not biocontaminated, you will, unless things change at the last minute, have a registered report in 2025 to report all your plastics in Canada. And this is an example of a new one. You're like, this is new. So one of the things about new, which is very different, is when you deal with a legislation that is one you've had for a while, it's changed, Prop 65 is changing, et cetera, at least your other stakeholders, your management are used to the word. They're like, hey, it's changed, there's more to it. And it'd be, okay, that sucks, but that's okay. When you have a new regulation, you're more likely to see your management go through the 4 stages of grief. You're gonna have denial, you're gonna have anger, hopefully you get acceptance. You get a whole bunch of good stuff. So it's going through a bunch of these parts. So this one, for example, a person who it applies to is a person who's a producer of a plastic product. You're going, well, my electronics is not a plastic product. I'm like, yes, it has plastic in it. By the way, plastic for this is what you think of as plastic. Rubber is also a plastic under this, as are the amorphous plastics, epoxy. So your circuit board material, epoxies in it. A producer is a brand. If you're a brand owner and you reside in Canada, no matter if somebody else is importing it, if you have a Canadian division, it's that. Or if you have no division in Canada, then it's your importer into Canada. It's your distributor or other that brings it in. Plastic products include, amongst other things, packaging, single-use plastics, and electronic and electrical equipment, including medical devices excluding implanted or infected devices. So your invasive medical devices are implanted, they get infected. Their plastics don't have to be reported, but the capital goods or non-infected items would. So electronic and electrical equipment, I have so much trouble saying that because it's inverted what the EU is, which is electrical and electronic equipment. So by September 29th, 2025, it's a funny date, you have to report for the 2024 calendar year. And that's the identity of the resins used to make plastic products, the source of the resin, virgin, recycled, biodegradable, used to make the plastic products, the category, subcategory of the product, single, reusable, electronics, etc., and the total tons placed on the Canadian market. This is the first year. In the following years, they're going to ask you more questions about how much you collected and recycled, but that's a little ways out. That is coming in the future. So, for example, in this new regulation, just to be complicated, Canada doesn't use the 1, 2, 3, 4, 5, 6, 7 codes for plastics. These folks use the ASML variant codes. I think they invented 281111410 ABS. Awesome. So imagine reporting ABS resins, which are pretty common. ABS resin 281111410, 5 tons. Virgin fossil-based conventional resin, pretty normal. And your category is category 11, say medical devices, EE, or category 2, telecom, or whatever you happen to be. PVC resins 281111420, 1 ton. Virgin fossil-based conventional resins. Again, this is medical devices, but it could be telecom, and it could be consumer, it could be products like televisions, etc. So you report by resin by their ASML variant code. So this is a new one. You're going, this is new. Yes, this is new. It still can be diverted, but right now we're looking like reporting in September of 2025 for your 2024 sales in Canada. This is an example of new. And you can see why you start talking about this to management, you might see the 4 stages of grief. Probably starting with somewhere in denial and hopefully ending with acceptance and maybe anger in between. Probably some raging of the stupid government's trying to prevent you from selling stuff and the usual drill. So one of the things, normal, I've been in this business almost 20 years now. It's a pretty normal thing because we get more new things, and the new things are more likely to trigger the different stages of grief. So the other exchange could be the regulation changes, like the scope changes, like the new Prop 65 warnings, which have been regurgitated, restarted, or the change in the derogations or exemptions to reach and pop. So the scopes have changed. So, for example, as a good example of a change, the new California proposition short form warnings, which we've been talking about on and off for years. So they went through a long consultation process a couple of years ago, and for better or for worse, they didn't finish the consultations in the time required. So that basically, OE is allowed to make this new change, but they have a certain amount of time to complete it in. And if they didn't, they lose the legal ability to do so. So they restart the process again. But they're not starting from the beginning. They're starting with the answer they had at the end of the last one. So it should be implemented pretty soon. So there's a consultation going on right now on the basically end result, and it's pretty well the done deal version. And it ends December 20th, 2023. And again, that hyperlink will take you to the new text. The summary, is a bunch of other little details, is today, when you do a short form warning on the product, you don't have to say a substance. You can just say warning, cancer and reproductive harm, Government of California website. The new one, you have to identify at least 1 reproductive toxin if you have one, and 1 carcinogen if you have one. If you happen to have a substance like lead, which is both, you can just identify lead. But you actually have to say a substance in the new one. And so this is a change of a regulation that currently exists. And it's quite different because if you don't have the right label, you won't be compliant in 2 years. So it also has 2 different options. You can say risk of cancer from exposure to, well, let's go for reproductive harm, BPA, and risk of cancer from exposure to DINP, and reproductive harm from exposure to BPA. See this website. Or can expose you to, again, the name of chemical, a carcinogen, and the name of the reproductive toxin, a reproductive toxin. See the website. And if you have lead, there's a slightly different one for lead or DHP, which happen to be a carcinogen and reprotoxin. It's funny, lead's a reproductive toxin. DHP is actually a developmental toxin, but they're both counted as reproductive. One affects, the number of swimmers a male can produce, and the other one has an effect in the first year of life, and DHP creates the apoptosis effect that creates attention deficit. They're both reproductive harm, but one is the ability to reproduce, and the other one is a developmental toxicity. They both count under reproductive toxicity. So you actually have to state a chemical. So you have to know what it is. You can't just slap a label on without a chemical on anymore. So the consultation ends December 20th, 2023. It's a pretty well done deal. So it could be published as early as March or so, 2024, and then it goes into effect products 2 years later, so around March 2026. So for example, and this date is all based on the manufacturing date of the item. So imagine they publish it 1st of March 2024 next year. That means it goes into effect 1st of March 2026. If your product was manufactured February 2026, a couple months earlier, even though it might not be sold to the end customer until July or October 2026, it doesn't have to meet the requirements. It's based on the date of manufacture. It's a little bit easier to control that way too. So it's based on the date of manufacture. So that's a change. So this is one, when you explained it, the management, like you'll have to explain, you have to do work. Your management is probably more cognizant this exists, and you've already done work in it. It's not a new thing. If you look on the web, there'll be a bazillion references. Look, you try to find the plastic registry in the web in Canada, you're gonna have a lot more trouble because it's so new. It's a new thing. So this won't have the same level of anger and denial and so on and so forth. They won't necessarily be happy with it, but this has also been expected for some time. Another one, the substance list change. And this is the most common one. You'll get 8 to a dozen of these a year where the regulation hasn't changed, but there are more substances regulated on. The most common one being the REACH SVHC list, which updates in June or December, sometimes July and January if they don't get published in time. So we're going to have one in a couple weeks. This one's pretty innocuous. Or the new REACH formaldehyde restriction. So all basically consumer-like electronics has a formaldehyde gas outgassing restriction in 2026. The REACH microplastics restriction, which is an exciting new one. It's just different. It's exciting in more of the Chinese proverb type way, or interesting, exciting. POP has the new PFHXS restriction, which is pretty nothing because you can't have PFHXS in a physical product. It's not a degradation of anything in it. We've never seen it in the product. The only place it's ever seen is related to a firefighting foam from about 20 years ago. There's a chemical reason why you don't end up with this in a physical product. You end up with PFHXA, not PFHXS. It's kind of a nothing restriction. Additions of PFOA into chlorine plus to restrictions under the Canadian prohibition. California Prop 65 is about 3 substance updates a year. So there's a lot of change like this. So these are where it's the regulation we're working on. The scope hasn't changed, except for they've added more substances. So for example, microplastics, which is not your typical substance. Again, that hyperlink will take you to where the legislation is published. And it restricts microplastics in mixtures, not articles, or regulates. It doesn't involve articles at all. If it's consumer, there's restrictions, and there are different dates depending on what your product is. And this is microplastics in mixtures, chemicals and stuff like that, not physical items like bones. So the rinse off microbeads in soap is basically banned October 17, 2023. Then it goes on through a bunch of things. Consumer medical device mixtures, their microplastics, which is very few products, is banned October 17, 2029. So, for example, if you have the when you get the dental impressions and you have that goop in there, what touches the patient, that can be seen as consumer mixture, and it wouldn't be allowed to have microplastics. I wouldn't see why it would, but it was not after October 17, 2029. Now, there's a bunch of other things, and then you get to makeup, which it's allowed microplastics to 2035 because makeup is so much harder to redesign than medical devices. No, true thing. That's actually one of the ways they got approved. Taking glitter out of makeup was justified as being harder than redesigning a medical device. Now, I do think the medical device people are often convinced, the regulators, that things are much harder to redesign than they actually are, but this is nothing compared to what the makeup folks did. They don't even have to say they have microplastics in the product until 2031. I can literally look at the ingredients list and tell you in 2 minutes, and that's because I'm trying to find for a minute and a half how to explain the chemicals. Yes, but this is consumer mixtures have restrictions. Professional mixtures don't. So oversimplification, there's lots of detail, and I don't want to take up all your time, even though this is interesting stuff. Well, to me. Consumer restrictions are starting in 2023, and they're scaled all the way out to 2035. You can still have glitter or your setting powder, which is microplastics for your foundation, which I only learned about a month and a half ago because of microplastics. they're allowed it. Industrial professionals don't have restrictions. They have labeling and reporting requirements. So you can use microplastics in mixtures, like in your lab reagents or whatever, but you have to label it, and then in 2025, and then you have to report it to the European Chemical Agency in 2026. Now, labeling is really instruction. They call it labeling, but it's really instructions for disposal. And labeling for industrial professional mixtures can be the SDS. The safety data sheet has to have some disposal requirements, has to identify their microplastics present, etc. I'm not sure which section that's going to go in, but that's where it can go. So, for example, imagine one of the most common source of microplastics in the US, outside of glitter and makeup, is fishing boats. That outer paint, that glittery paint in the sun, that's got microplastics. That's what it glitters. It's not rock mica, it's plastics. So that microplastics, what glitters, is microplastics. So the way this regulation works, if this is the EU, you cannot sell a bucket of paint with glitter in it for you as a consumer to paint your boat. It's banned in consumer uses. However, you could sell it to the paint shop with instructions for disposal, and they could paint the boat. And then the paint shop could, or whoever else can sell you the boat, because it's an article, once the glitter's on it, none of this counts anymore. So they can sell you the glitter, colored boat, as long as the paint shop did the work. They will have to then, in Europe, whoever gives them the paint has to label it, and they have to report each year how much of their glitter they believe goes down the drain, which hopefully most of it goes onto the boat and doesn't go down the drain, but that all has to happen. So consumer mixtures will have restrictions. Professional industrial will have labeling and reporting. And so this is a new substance with new rules. It's almost like a new regulation. As opposed to just the SVHC updates are basically, hey, the next one's going to be another 8 substances which are declarable if they're above 0.1% by weight in any component. So some of them are a little more straightforward. Prop 65 is a little more straightforward, except for some of the substances, they're all exposure related, so their functional regulated limits are all different. But you have substance list updates. Now this one, a lot more companies are aware of and are more likely to be lax about it, saying, well, it's just more substances. And enforcement on the reporting is a bit poor. Prop 65, less so. This microplastics, less so. Formaldehyde, less so. And we'll see from there. Or you could have a change in enforcement. And this isn't a regulatory change, but it's almost more powerful than a regulatory change. Whenever we see a change in enforcement, we see a lot more activity. So right now in Prop 65, it's all the PFOA prosecutions, especially in waterproof textiles, but a variety of other situations. That's a change in enforcement that will causes. You'd be surprised how much enforcement of your product changes your compliance program dramatically. And then the new FDA direct mass spec testing is probably the most radical and effective new enforcement method we've seen in a long time. Nice thing about, all enforcement was always happens behind the scenes. It's amazing how much we see because we help people, but it's not public. The FDA on the food side have published what they're doing, so there's at least references of what they're doing. And they're using the direct mass spec, using direct mass spec. So to test for phthalates, flame retardants, and polyaromatic amines, PAAs, in food contact materials. This is FDA food contact. They could also bring this over to medical folks. And what they're basically saying is, hey, there are a bunch of flame retardants that are not supposed to be in your food contacting materials. And even if they're there trace, under good manufacturing process, they're not allowed to be there. So therefore your product's not compliant. And so what normally we have to do for LC or GC, liquid chromatography or gas chromatography mass spec, is we take something like this, then we have to cut it up in little bits because we want as much surface area as we can get per volume, put it in a little, honest to goodness, it's like a first year university or second year really for me, glass beaker, and it puts a solvent in it which extracts. We don't really want to change the chemical property, we want to extract it. It's one reason why we cut the material up to increase surface area. We have something which stirs it around, which could be, if it's US method, it's an ultrasonic stir. The European method, it's a soxylate, basically boils it up and it goes through a thing and it comes back down again. It's all boiling action, basically soxylate. Fundamentally the same thing, but just different ways to stir the solvent around. Then eventually you take it off and then you extract some of the solvent out, which hopefully has whatever you're trying to extract in it. Then you often just have to do a pH or other change so you don't burn the chromatograph. Then you inject it in a liquid chromatograph or gas chromatograph, and strangely enough, something pushes it. And the chromatograph, the way it really works out is different materials will grip glass differently. So if you have a glass near you, you'll often have the water goes up the side like a meniscus, and that's because of its polar attractivity of the water attraction to the polar glass. Glass is really neat because it's polar. Depending on the material structure, it'll have different gripping onto glass, and every single substance basically has a different attraction to glass. And so if you fill these tubes with glass beads and push it through it, certain chemicals at a constant force, certain chemicals go through faster than others, and that's chromatography. And then it's something smashed to the other side, knocks off pieces and charged particles, and there's a really neat way to weigh materials. It is literally, imagine you take a molecule, knock off an electron, oversimplification, make it plus, so like DHP plus, and then you fire it, this plus, through these two electrodes. One is plus, one is minus, and the plus and plus will repel, and it'll go towards the minus. And so it will go, ooh, as it pushed through, it'll go towards the minus, so it'll go like that. And it basically then hits the target in different places, and it's set force, and then wherever it hits, you know from the distance it went what the acceleration was, and so it's force equals mass times acceleration, F equals ma, and that's how you measure the mass. It's kind of neat, and so that's a very involved whole process, and often takes a week and a half or 2 weeks, which is not great for enforcement. The new direct mass spec, which we have one coming in tomorrow, likely, or later this week, we've been using one for a bit, is you get a little piece of this off. You take a sliver, smaller than the size of a grain of salt, you put it in the machine. It uses a heat beam or other heating method to then heat it. Most of these chemicals have are volatile at high temperature. They come out, and then they can measure it directly. And so you just cut a little piece off, and then about 10 minutes later, you have whether it's tetrabrome bisphenol A or deca-BDE or DHP or any of those, and it's like that. So they suddenly can then have a shipment come in, take out one of the spatulas in that picture, take a little piece off it, and they'll know 15 minutes or 20 minutes later whether or not it has a flame retardant that's not allowed, or a plasticize, or an amine. And that's changed enforcement a lot. So they can test it import, and they have been on the food side. Someday they're gonna probably port this over, once they do the quals, port this over the medical side, where to prove there's stuff in the medical products that's not supposed to be there. And they're holding shipments, and basically say they find it, it's a really good machine. They're almost always right. And so you either have to replace the offending part, like the shelf in the refrigerator, or you have to take the whole thing back home. And it's rapidly changing a company's approach to compliance. We're seeing 40-foot containers, stuff like that all the time on the food side. So this is a big change in enforcement. It's amazing when you start doing that, how it changes your program. Recycled material is a bit of a problem that when you have a plastic, by the way, this is not one plastic. There's a base plastic, but the colorant's a separate plastic. And between the two of them, they could end up with some level of regrind or contaminating material. Either the colorant or the plastic itself, especially as you go towards cheaper, this becomes more and more likely. And so this is an extreme difference in enforcement. If more regulators do this, if somebody, say Sweden, decided to take this up and go after phthalates for ROHS, they would destroy things. It wouldn't be close. The amount you can do in a fast order without a complicated lab, it's a little bench shop thing, is spectacular. So this is also a type of change. This is also likely to affect things. One of the things when we talk, like for food contacting people, Europe, by the way, has a list of things they're rejecting for, and it's in the restricted substances, and it might surprise you. A lot of it's polyaromatic amines in black nylon, really common. In the medical side, there's all this pressure on nitrosamines, and a lot of people are trying to test for nitrosamines, which we do. But they're actually, and there's recalls. If you look at pharmaceutical recalls, you'll notice that they're disproportionately nitrosamines. Nitrosamines aren't from the pharmaceutical. It's actually from the vulcanizer in the valve in one of the gaskets in the machines used to make the pharmaceuticals. And there is a combination of a nitrated substance in the pharmaceutical that reacts to the vulcanizer, and that creates the nitrosamines. The nitrosamines are never added. It's only a reaction between the vulcanizer in the nitrile seal and the pharmaceutical, which is creating it. So that's funny when people are like, hey, this is pharmaceuticals, I need to test my gaskets for nitrosamines. I'm like, well, we could, but what actually happens, there won't be any nitrosamines in your product. It's actually this vulcanizer family that's commonly used to vulcanize nitrile rubber that reacts with the pharmaceutical to create it. And that then changes. Of course, when you get recalls, that changes and things. So next step, how do you keep up with all this? It's one thing. And then how do you understand it? Like knowing it exists is one thing, understanding it's a different thing. Also, and then what we're going to talk about later is everyone else. How do you communicate it to other stakeholders? Like you might eventually get the arms around it, but how do you communicate it to everyone else? And one really important one which should be here is then how you actually implement it. This is cool. I know what to do. I know what's required. I understand it. I've communicated with everybody else. Now, actually, how can we actually do it for our products? So we'll talk about implementation. So this is what we do for a lot of companies. And a lot of these, if you have the really significant knowledge, you can probably possibly do internally, but I'll give you understand what we do. Quarterly updates and substance risk assessments and annual product updates and education and the global matrix. And I'll explain what these really are. So one of the things we have to focus on right now is we have a thing called the global matrix we do for companies. And this is about the today. And it's a reference document for all applicable regulations. Again, what you're most likely to be non-compliant for, the things you didn't know about. And so, which includes stuff today, not just new stuff, but today. So we create a matrix, sort of a matrix of all the different requirements that apply to your products. We definitely identify which ones are applicable. And then for each one, it's like, here's the country and jurisdiction, here's the legislation, here are links to the legislation, here's a summary, here's the scope, like products, here are the deadlines. And then we also look at impact. And we do sort things because we suddenly realize, oh my goodness, I got these 20 regulations I didn't know about. We can't do all of them once, which is not possible. So we also focus on impact. Which ones are basically restrictions versus labeling versus warnings, and which ones are enforced. So the ones, of course, restrictions that are enforced are the most important ones. Those are the ones that are business impacting. So we try to group them. Group 1 is business impacting, can be stop ship issue. Group 2 is business impacting, but not likely to be a stop ship. And group 3 is not likely to be business impacting and not likely to be enforced. So they're required, but it's one of the ones you get to when you get to it. And then we put links, and then we also run a little software in behind that checks this all the time to make sure links haven't moved. Often when a division like Environment Canada becomes Environment and Climate Change Canada, the links move. So we have to check that all the time. So this is the today. We do it in Excel usually because you can sort it by jurisdiction. It's just much easier to handle, or by impact. These are the ones that are high impact to make sure you're getting those done. But we make sure it's easy reference. You can click on the links and go somewhere useful you can learn more. Again, this is not expected to educate you. This is really just if you know what to look into more. We also often use this as a starting point when we create a supplier specification or a design specification for your products. It's the today. One thing we do, easily most common, we do this for about 80 to 100 companies, it's quarterly updates, where we provide our monthly, we definitely do a lot of monthly too, where this is about ongoing. So one is a level set of today, one is an ongoing. And the ongoing is we set every quarter or month and then explain the changes. It could be new regulations, it could be changes in scopes of regulations, it could be new substance lists, or it could be changes in enforcement. We actually approach all 4 of them. And then whether it applies or not. A disproportionate number of the ones we explain in our updates are ones that don't apply to you. We often, in a lot of companies, use these systems which warn them about new regulations, and then they flag us, hey, this is a big problem for us, and then we have to explain, no, it isn't, because this is the scope and it doesn't apply. And so we do a lot of that. A disproportionate amount of the ongoing stuff is actually explaining why the regulation does not apply to you, or why it doesn't apply to you very much. Now, some of them it does apply quite a bit, and so you can also do this internally with your own stakeholders. But when we do it, the funny thing is there's no cost difference. If you invite lots of people, it doesn't affect us. And you also have an expert there you can ask questions to. When we explain the new substance restrictions, say for the battery regulation, which have a bit of a mistake in it around cadmium restriction, you can ask questions. Okay, you can ask this, or like, what date is it based on? Is it based on when it was imported? Is it based on when it was manufactured? And sometimes we'll be like, good question, we'll get back to you, and we will. So this is easily one of the most common things. We do so much of it, you get to benefit with everybody else's knowledge. We also get to refine the work over and over again, where you're not seeing something was cobbled together for the very first time. It is definitely flavored for your products because everybody's different, but it has the advantage. This is about ongoing, and we like the ability of, we don't like just the service to notify people. There are some uses to it, but it's a lot of understanding difference. And not everybody has the time or knowledge to go through it all. So instead we say, hey, for 1 hour, every month or every quarter, we'll explain it. And if you have more questions, feel free to ask, but at least we'll explain it. In 1 hour, you'll have a very good starting point. And that's how we normally handle ongoing, which includes this. So the substance, now the technical. So a number of times the change is a substance list change. They're new substance, new SVHCs. Well, it may or may not impact you. And if they do I have to redo my SVHC data gathering every month, every 6 months? A, it'll mostly be lies anyways. B, no. a lot of substances don't apply to you. It's usually fairly restricted. Or sometimes you're going to have tons of this. So you could research or just declare it because it's everywhere. So we call it the technical. As much as the today is important, as much as the ongoing is important, there's a technical aspect. There are chemicals with big, long, fancy names. One of the good examples here is melamine. Melamine is not what you think of as melamine. What people commonly call melamine, or you go by a kitchen, you say, I want, we're going to get a melamine countertop. It's not melamine. You're like, yes, it is. It's called melamine. No, it's not. It's melamine formaldehyde. It's a different chemical, but it's melamine. No, they're different. It's got melamine in the name. I agree. It's like saying DHP, which is a phthalate, is the same as your shirt, which is polyester terephthalate. They're not the same thing. They're different chemicals. Melamine formaldehyde, if I put a picture of melamine and melamine formaldehyde, which is a big thing, you see to be quite different. Like there's one piece that's kind of similar, but it's not melamine. What you normally think of as melamine is melamine formaldehyde. It's a different material. It's actually not melamine. However, there is a very common flame retardant called melamine cyanurate. And you're like, well, just explained that that's not melamine. Funny thing, I know, it's really weird. Melamine cyanurate, it's actually melamine and cyanurate, and they're not well bonded. It's called Lewis bonding. It's a long story. It has to do with the chemical structure, but they're actually not bonded together. So when you have melamine cyanurate, it's almost like having salt in water. They're separate. So when you're using that flame retardant, you get melamine on its own. And when you're halogen free, which is big rage for a good portion of the last 10 years, they use melamine cyanurate all the time. It has melamine in it. It's not banned. You have to declare it. Tetrabrom bisphenol A is the main flame retardant for years in ABS. We see it everywhere. By the way, in old school, if you have the old, leaded resistors, they still have the color bands around it. I know I'm dating myself. The ones, they're flame retardants for those are tetrabrom bisphenol A all the time. There's lots of other uses, but especially when you go way back, all the ABS was. And those little leaded resistors with little stripes. And if it's kind of back in the day, you had to know which stripe meant which resistor value. And it's kind of a log scale. It's kind of neat. Those types of resistors are normally tetrabrom bisphenol A declarable. So it's kind of funny to say, hey, we can do the research, or do you use those kind of resistors? Yes. Then declare it. I mean, you can go through the effort, but you're going to have it. So we do what we do, and it's actually part of the quarterly update, monthly update stuff. So it's included with it, where we actually review all the new substances. Like the ones in January this year had quite a few, 9 new substances, of which 4 could be in your product. The third one was really phased out, BTBE, and it's not there. And we know a lot more about it now. Melamine, tetrabromophthaleate, and tetrabrom bisphenol A are very common in electronics. Might be common to the point of just declaring it. So there's a technical aspect. How do you keep up to speed? The technical aspect, because otherwise, if you try to follow every chemical down every rat hole, it's not going to work. So the other neat thing is we have a project ongoing where we're just picking skip declared parts and then testing them, and we're finding so far 0% of the parts we test agree with the SVHC declaration. Most of them are just completely wrong. The data gathering, the only reason people got away with data gathering for so long is the enforcement's been weak. Someday we might acquire something in skip database where the data agrees the test data. Normally it doesn't. It's not heavily related. So it's pretty funny. They normally don't have, the substance they say is there is not, and then the substances are there, they don't. It's a good thing that on average. Now, fortunately, a lot of the SVHE is declarable. We're seeing more and more restrictions. PFOA is a good example. Your phone, your laptop, your tablet are probably all banned in the EU right now if the EU knew what to look for. There's a particular material type that connects the graphics card to the screen that for a technical reason has PFOA above the regulated limits and would therefore be non-compliant. It's not there on purpose. It's a fundamental structural element of how the polymer degrades, but it is non-compliant. Your hard drives are all non-compliant. They have a little waterproof membrane filter. It has to do with the way the ePTFE is created. It is PFOA, it's banned. Hard drives are now universally banned in the EU. The EU doesn't know that, but there's a lot of surprises. There's a technical element to this whole thing. Annual product updates. So you can do this yourself, and the way we do it is we don't try to hodgepodge unless an emergency updates. And we test products all the time. It's funny, one of the arguments with data companies like, hey, you test something, it's a shot in time, you can't update it. I'm like, data gathering is a lousy shot in time, which is wrong, and you have to try to update it. Testing updates, no problem. What you do is you structure, but you have to have a plan. You can't be in a bunch of bad words there. Can't be an idiot about it. You have to have a plan. That's fine. That's normal. One of the big things we always look at it is there has to be a better way. We used to data gathering way back when. People wanted to pay money for it. It just didn't meet our quality requirements. It became, when we had to tell companies what the data reporter was and we knew it's quite wrong, eventually became, we couldn't do it for a number of quality and other reasons why we got a data gathering. We use it for very specific things like batteries and some first primary plastic suppliers, which have some very specific information. But generally we find data gathering can't, I know when we're providing the data, how dishonest it is. And so we had to keep out of it. When you have a test lab, you get to see that it's laughably wrong. Again, benefiting from non-enforcement. As that's changing, people are going to be a bit surprised. It's funny, the way the SCIP project worked for us is we want to, one of the things we look in testing, as much as you can get a control sample, you really want a real world sample because the control sample is too pure, too good, too simple. So we try to get real world samples, and of course using SCIP to identify products that had certain chemicals and see them more in the real world. And we kept bringing them in, and they kept saying, nope, they don't have it, nope. And then we're like, well, what happens if we try one that, product in here, it didn't declare this, let's look at that part. Yeah, it had the one we thought would be there, not declared. So anyways, so TSCA, so when we try to do it, we try to look at what we're gonna do for 2024, and it's usually for requirements in 2025. So like this year, we're looking at the PIP 3-in-1, even though that regulation might have just changed or is in changing. So the only place that PIP, the flame retardant, is found is in wire and cable, and wire and cable might actually get an exemption momentarily. The TSCA PFAS reporting for May of 2025, the new upcoming Dechlorian Plus and MCCP restrictions that are REACH. And of course, I was talking about tetrabromid bisphenol, melamine, and tetrabromophthaleate, the SVHCs that are quite common. If you're medical, it's the updates to MDR ATP20 for invasive or implantable devices. Lots in the PFOA side. It's amazing how much the PFOA and longer substances are in products and how non-compliant they are. So we're making sure that problem is dealt with, or at least to know what exemptions to ask for. And then POP's got the new PFHXS. Of course, you see no components around it because it doesn't exist in physical products. And there's a whole chemical reason why it doesn't. So this is when POP, when the PFHXS restriction came along, we're like, well, so this is what you do. Nothing. It can't be in physical products. I can sit there and explain with chemistry, and if you want to, I can. And we've tons and tons of test data to back it up, but there's a whole chemistry reason why it doesn't exist. Its cousin, 6,2-fluotelomer sulfonate, which is also a hex, all the time, it's one of the building blocks, degradation of the building block of Viton. It is 6,2-FTS, and there's a whole reason why it exists, and this one doesn't. PFHXA, the PFOA family of hex, all the time, because it's a normal degradation product. It's just the way it all works. And I showed him pictures, like it's pretty blatantly obvious why it ends up this way. So it's a pretty irrelevant restriction. So what we do is we up revision, the POP to the new revision, knowing full well we don't have to do anything for PFHXS. So we always plan it around a year. So this is compliance, this is implementation. Knowing is one thing, communicating to everyone else is also important. Understanding is important, but actually being compliant is kind of the point. So we try to focus on the outputs, and we do it usually by creating a compliance plan, a consolidated plan. Man, anything we've ever tested with the last 5 years, after that it gets a little tough. In the last 5 years, we can update to the 2024 to 2025 requirements quite easily, because we can use a lot of the previous data, and we actually have a plan, we have a process plan how to go from, it was a 2018 test to 2019, 2020, 2021, how to actually update it in 2024. And it doesn't involve retesting everything at all. A lot of times the previous data gives us a tremendous information, or it's very selective things. Or in some cases, we could do the testing of this, but there's so many parts that are risk of it. It's an SVHC, why don't we declare it? And we definitely can, but it's gonna be there. So we create about, and so another way to look at it for yourself is look at also what we're doing in 2024. That gives you a good idea what you need to be working on in 2024. And when in doubt, we can do it for you. It's really specific. So one of the problems is data gathering is like this all the time too. We see what people have done for data gathering. It's disproportionately a snapshot of data that's wrong at any given time. And much saying, hey, we're going out and doing campaigns each year, they're incomplete, and often the parts that have, so the parts you're gonna get data for are often the circuit board components, which for a variety of reasons are pretty low risk and don't actually have those substances. They might have had them in ingredients once upon a time, but they don't in the end. Tetrabromid bisphenol A is complicated. It's the parts that are declared for tetrabromid bisphenol A are normally wrong, because it's normally tetrabromid bisphenol A diglycerol ether, which is a different chemical, by the way, and then tetrabromid bisphenol A. They're quite different. But there's a long, complicated reason. It's technical. And that's what I explained. There's a today, ongoing, there's a technical aspect, and then there's actually doing it, the implementation, the compliance. And then there's the education side we do. There's the everyone else. So this is one of the challenges you're going to have. I talked about a lot of things today, and when we do an update, one of the nice things you can invite as many stakeholders, you get more information, but there are other people who need to know what to do because they're designing or making your products or whatever they're doing, or buying your parts or whatever, whichever. So the everyone else. And there's the new stuff, but often you have to educate them on the current stuff. So even for us, you know, I look at ROHS. I've been working on ROHS since 2004, more or less. I have it pretty down by now, including the recast and the variations and so on and so forth, and why the exemptions are still in limbo and all that kind of stuff. But I'm like, hey, look, anybody's been hired in the last couple of years, we might not even done an education, so we have to bring them back up to speed. So we also do lunch and learns internally. The quarterly updates is a fantastic mechanism. So the neat thing is if you have one person attend or 20, it doesn't change the cost with us. But we do internally, we also do lunch and learns. Well, we sit there and, you know, lunch is a way to kind of lure them in with bait. So we explain something technical and explain it. But we have very set educational series. We can talk about what reach and explaining in really practical. And we also, as I get older, I use more and more practical examples and try to be more tangible. And so that's a big focus the way we do things. We try to become more tangible and say, hey, it's not like, hey, this is a fancy word. It's this thing here. It's this glue, or do you have one of these? And like, oh, yes, we searched a bomb. We have that. And that's what we try to be as tangible as possible. So again, as I mentioned, this is a big thing also to understand for your internal stakeholders, is this is growing faster than anything else. This isn't like product safety and EMC, which might have little standard changes, and they might, you know, request they have to do some other complicated test. You get whole new regulations all the time. You get regulations changing all the time, and your substance list will update 8 to 12 times a year. It's dramatic. So when in doubt, reach out. We're happy to help. Also, again, we're about to get the Q&A section. Feel free to submit questions as much as you wish. I have 1 or 2 minutes for a Q&A. One of the funny things, so I recently turned 50 or so, and it was neat. And I eventually saw some friends I haven't seen in a long time. And it's good. So when you go out to a pub with your friends, say when I was 40, it was more like you pick up the menu, and you go, oh, I would like the IPA. That's when I was 40. When I was 50 with my friends, pretty funny. It's basically, this is going to the bar. I'd like the IPA. I found that hilarious. It's unfortunate, but that's like the biggest difference of going out with my friends who are 50 now instead of 40. Is definitely the menu section at the pub is more of an adventure. Sometimes it's delayed by trying to find their phone in their pocket somewhere. Okay, so on to Q&A. So feel free to ask any questions about the processes, the regulations, and happy to help. And I hit the wrong button. Is the Canadian plastic scope based on hazardous substance or something else? No, it's literally the plastics. In a perfect world, which I don't live in a perfect world in this country, it's wonderful, but it's unnecessarily complicated at times. It'd be like the 1, 2, 3, 4, 5, 6, 7. So we know when you get a plastic and you're looking to recycle it, and you have a little triangle at the end. Yeah, like that, but not that number. We have our own 8-digit ASML variant code numbers. So instead of like a 1 or a 2, it's a 841121410. But it's basically the plastic. It's not a hazard. They're trying to find out what plastics are in products. So it's a mandatory registry. You have to report ABS and report polycarbonate and thermoplastics, and then there's the blends are a different category and a bunch of other things. And often the plastics like this are a different category than the rubbers, which are a different category than the amorphous ones, the epoxies. Epoxies are basically amorphous polymers. Another question there. It's mentioning PIP. Is it changing? Yeah, so PIP, the only place you find the phosphated flame retardant, PIP 3-in-1, has been in the little rubber boots at the end of connectors in PVC rubber boots. However, it looks like, and it's not final, they proposed an amendment, update to the TSCA PIP restriction, which exempts infinitely wire and cable, which takes out the whole problem for electronics. It's just in that boot. It's either in the heat shrink, which is rare, or in the little boot piece. So that's pretty good. Question about the US TSCA reporting, how to do it. because it's one of the things we're looking at this year. So one of the nice things about the US TSCA reporting, it's not, you don't report for every product, you report for your products, and you don't have to know which products have a PTFE seal in it or FKM gasket, or the barcode's fluorocoded. You just have to know across your products what your uses are, what's the max concentration for each chemical, uses for each chemical, what's the max concentration, and a rough breakdown of the uses. So 50% of the uses are for PTFE or as a dielectric, and 30% is a flame retardant, 20% is a lubricant, which it wouldn't be that percentage actually, but we'll use that. And then what you do for volumes, you create a declarable for each chemical in your products, and then you declare for each year how many products had those substances. And you don't have to know that product had 2 at PTFE, and that one had 7, and that one had 8, and that's not important. It's just the number of products with PTFE in it and the max concentration of the product. So what we normally do is we take representative products of yours and we test the representatives because it's easily the most comprehensive and fastest. And then we do a BOM review for the low-hanging fruit that are very application-based, put them together, create first a low-level declaration that we can remap into the US or state level, or Canada's gonna have PFAS reporting next year too. You'll probably see it March or so. Or you're looking at the EU REACH restrictions. We just map it up and then we create the declarable. And it's very straightforward to do. It's not going to break your bank. When in doubt, reach out to us for the US TSCA. We'll give you here's what exactly we do. Here's the cost. And if you don't find, better way to do it, and I doubt you will, one of the nice parts working with us, we have such tools and advantages together. That of what we do, that we can make things a lot easier and simpler. The idea is just make it really easy for you. And it'll be actually quite accurate. It'll be extraordinarily accurate, more accurate than basically any other method. Well, we're seeing, especially for the PFAS, what the data gathering gets and what we see are not that related. It's amazing how common the fluoros are. I mean, your frying pan, everybody's, hey, it's got a Teflon pan. Awesome, it's got 1 fluoro. Your average electronics is 20. It's not the same world. What is IEC 62474 DSL, Designated Substance List? That's a lot of acronyms, by the way. IEC's international standard. So 62474 is a pretty reasonable, actually, declaration standard. It's not super dynamic. It's not bad. They do update it pretty well. Doesn't benefit with test data much. It's more based on what goes into it than actually what's in it. But the idea is there's different levels of it. The designated substance list is basically these substances are regulated in some way, shape, or form, and we need to declare it. The challenge is it's so CAS dependent, chemical number dependent, and a lot of systems are chemical number dependent. You can't do PFAS, you can't do in CAS. Sorry, it's not going to work. Most of the declarables don't have CAS numbers. I'd say 40%, not most. Say 40% of the PFAS declarables don't have CAS numbers. They're like, that's impossible. It's a chemical. Polymers are not chemicals. They don't normally have CAS numbers. Find one for fluorosilicone. You're like, well, it's got this one. I'm like, no, that's the ingredient that makes it. It's not the one for the actual polymer. You need to be able to handle that. You get a safety data sheet from one of the main manufacturers of it. It won't have a CAS number because they don't have to. The SDS doesn't have to have a CAS number for it. It's quite different. But so what it is, it's a relatively intelligent designated substance list. And there's a couple entities that are pretty good substance list, but it's basically the industry standard where they've gotten together and agreed, here's the substance list. Now they try to do it by CAS number, which is, there's that problem. And there's all kinds of the full material declaration, which doesn't work at all because it doesn't, I'm a chemist, I understand not the mistakes. I understand what you're declaring as a CAS number has all the impurities, and most of what regulates in the future is an impurity. You can't use a full material declaration in anything in the future because most of the newly regulated substances are not declarable in a full material declaration because they're an additive of a polymer. Additives of polymers, under a lot of rules, don't have to be declared. You're like, but that's not right. I'm like, that's the way it's been. We could look at rewriting how SDSs are done, but it's not the way it is. Most additives for polymers don't have to be pure, and they have huge allowances for what's in, as do actually most chemicals, believe it or not. So that doesn't work out too well. So 62474 is not a bad substance list, actually. If you want to, hey, here's a substance list. Now, we don't normally do ourselves. If we do data, we do a supplier specification. We never do by CAS number. As a company, I find it amusing when a customer comes to us and saying, hey, our customer wants us to comply to this substance list, and it's an alphabetical list of substances. Oh, God. That's not helpful. No, when we create supplier specs, we put the regulation in because that's how the compliance is done. Saying you need to be compliant to this regulation, these, and this is how you identify which revision. The important part is what regulation you're compliant to, what revision. Declarables are also important, but they're not as important as the restrictions. So we create provisions like, hey, you need to provide us the declarables, but they're not the end of the world compared to the restrictions. So they need to know what they have to be compliant to. Giving them a substance list in alphabetical order or a designated substance list is not helpful for supplier specification. It's too complicated. I am probably one of the best chemists in the world at this, and I find them a little daunting. And sure, I can go through a chemical list and actually know the chemicals by name most of the time, but I'm not normal. And trying to do that practical, it's better to do things by regulation. So the designated substance list, now fortunately also the 6474 is not bad about doing that by regulation. There's a lot of intelligence built in. It's still only as good as the data goes into it, but it's not the worst standard. Again, any substance data is not important, that important because it usually isn't correct. The important thing is they've committed to compliance to whatever it is. And then the way you handle any risk of penalty is you test something to show you've done the work. Again, if you've done data gathering to the nth degree and you're non-compliant, you're still penalized because the national authorities don't care about supplier declarations because they're used to dollar store type stuff, which the supplier always says it's good. So every time they have enforcement, they find phthalates and something and say, well, my supplier said it was good. They're so used to that, they don't care. You have to test something representative. Perfect. Well, that's it for the questions. If you think of something else, feel free to reach out. You like any of these things, it's amazing how effective they are and help you keep you up to speed. Of course, you can do some of these things internally. Definitely recommend the education part because you have this everyone else problem. Not all of us talk, a lot of us talk chemistry here. It's still a lot. So thank you very much for coming and a pleasure hosting everyone. I look forward to talking to everyone again soon.